Great. Hi, everyone. Welcome to week 6. We're going to do group by and summarize this week. So quick outline, announcements first, then demo, then breakout rooms. In terms of announcements, for those of you who are doing a C1, you're going to get a Slack message from Jody, who is our person heading data journalism next year, to meet either next week or the week after. What Jody wants to see with people is basically the storyline that you guys have for your C1. What question are you guys trying to answer? Do you have a data set? And what sort of of relationships are you expecting between your variables? So we'd strongly suggest having one, a question, two, a data set, and three, start thinking about possible plots that you could be making, make them if you can already. And then we got a teaser plot on the right here. This is the sort of thing we're going to be able to do in like 1 or 2 weeks based on the things that we are doing today. So today's kind of like a bit of a heavy week. So just like interrupt us if you have any questions at all, because these are a bit of complicated topics. Okay, demo. Let me just load these packages super quick. So I'm just gonna start going through what Nico wrote here. One of the most used functions in R is group by, and this groups the data by the variable that you specify. For example, in the example that we did last week with Star Wars, you could just group by each planet, and then you could apply a function to, let's say, figure out what the mean height of each planet is, rather than just getting the height of each individual part of the planet or character in the planet or whatever. So yeah, this is slightly complicated. So just let us know if there's any questions as we go. We're gonna still stop at every point. So let's just load empty cars, a data set that comes with Tidyverse. So we just write the name of the data set and then just run to print it. And we can run the metadata by just going here and clicking F9, F1 on the keyboard. At the bottom right, you're gonna see all the variables here, and all the 11 different ones are named. So imagine that I want to group my data by cylinder, for example, by number of cylinders. So let me just make a chunk here before empty cars group by sil and see what this does. And summarize. You're gonna see group by and summarize coming together very often. So what this line of code does, is basically it gives me the 3 different types of cylinders, 4, 6, and 8 that we have. But it's actually not doing anything else rather than just printing out the different groups. In this case, we have 3 groups per cylinder because those are the unique values. But let's say that we want to find the mean MPG, which stands for miles per gallon, for each group of cylinders. So inside the summarize function, instead of having it empty, we create a new variable called mean MPG and set it to the mean of the MPG column that each of them has. So now instead of only getting on the left the different groups of cylinders, I get the mean for each of these different groups of cylinders. Questions up to this point about how this works? In the chat or just speaking up? Okay, sounds good. So recap, group by puts them into groups, and then I pipe the result of that into a summarize function, which creates a new variable, in this case mean MPG, which goes on the left of the equal sign, and then on the right goes whatever I want this function to do. In this case, it's taking the mean function, and it's taking the MPG column, and it's getting the mean miles per gallon for each different cylinder group. Great. Summarize is like mutate in the sense that it creates a new variable, which in this case is mean MPG. And summarize is different from mutate in that summarize eliminates all the variables that are not used inside the group by statement. So it would eliminate all the other ones, the other like 10 ones here that are not cylinder. And summarize only leaves the new variables that are specified within the function. In this case, it will leave cylinder because it's in the group by, and then it would just leave mean MPG, which is inside the summarize. So all the other variables are going to be dropped, and that is different from mutate. You can also group by more than one variable. In this case, we'd be grouping by cylinder and gear. Let me run that. So first, I get all the possible combinations between cylinder and gear for like 4 cylinders, then for 6, and then for 8. As you see here, first it's going to group by the different numbers of cylinders, in this case 4, 6, 8 in that order, and then for each of those different groups of cylinders is going to try to find the combination between gear. So the order in which you put these is important if you want to get a specific result. And then we're just getting the mean, but instead of getting the mean for example, 6 cylinders alone and then 8 cylinders alone, we're getting the mean for 6 cylinders and 3 gears separately from, let's say, 6 cylinders and 4 gears. So as you add more variables to your group by statement, you're gonna get like smaller and smaller groups because all those different combinations between cylinders and gears are gonna start being available. Any questions up to this point? If not, I'll just read this. So we group by number of cylinders and number of 4 gears. This creates further subsets of the groups. And one important note to keep in mind is that as you group by more and more variables, the subsets become smaller and smaller. Hypothetically, you could group by all the variables, but then of course the average will likely be of just every individual unit. So like if you group by all the variables, you probably get like unique rows of combinations between those. So it would not make sense to group by all 11, but it would make sense to group by a smaller number of those. And as this chunk shows, you can actually output more than one new variable. In this case, mean MPG was the variable that we use. You can also output more than one, which would be mean displacement here. Let's just run that. And so here we have the same thing as above with mean MPG. We just have a new variable called mean displacement. Great. Any questions up to this point? And what Nico says here is that there is no cylinder to gear ratio that maximizes your miles per gallon or displacement at the same time. Cool. Okay, moving on, instead of group by and summarize to group by and mutate, the key difference between mutate and summarize is that mutate leaves all of the other variables. So it will leave all 11, which depending on the situation might be useful. So let's rerun the last chunk and use mutate right here instead of the summarize function. Mutate, as we said, leaves all of them and then creates these two new columns, mean MPG and mean displacement. In this case, remember that we're grouping by cylinder and then by gear. However, this is not being very useful, right? Because before we had like 4 cylinders, 3 gears, 4 cylinders, 4 gears, etc., like in a super orderly way. This time, it seems like we have all, if not most of the rows that were in the original table. Like we have 6 cylinders, then gears over here 4, and then 6 cylinders, and then gears 4. Why? Because all these variables in between that are now being shown in the table, they make those two columns unique. For example, the weight of this first row is different to the weight of the second row. So the rows are unique now, and that makes them go separately. Although the result that you get for mean miles per gallon and mean displacement will be the same across both rows. If you want to do something that has like the common mean displacement a different variable, or the common displacement, whatever, in like the same variable, and have it be repeated, and still show like all, if not most of the rows as it's doing here, then do mutate. But otherwise, as you can see, it's not as clear. Like the breakdown of the groups is not as clear as it is with group by and summarize, which gives you much cleaner tables. Any questions about this? As Nico says in this scenario, summarize is better than mutate because it's hard to tell how mean miles per gallon and mean displacement compare to everything else, since they repeat and appear relatively arbitrarily without being able to see all the different values. And then group by and mutate are going to become more handy when doing visual analysis, since losing columns can sometimes be a problem when you want to include those in the graph. So for example, imagine that I wanted to include, aside from cylinders and displacement, or inside from cylinders and gear, I wanted to also include, let's say, weight in my graph. I'd have to keep this weight variable inside it. So mutate might be more useful than summarize if there's an extra variable that I want to keep. But otherwise, it just separates the groups and it makes it harder to visualize the data in your table. Okay, next is ungroup. So when you use group by on certain variables, they're going to remain grouped in that chunk that you're working on. And this can be hard if you want to reanalyze the data aside from those groups or graph the data separately. So you use ungroup for that. You just pipe whatever you have. In this case, this is the original code. This is the group by summarize code. And then the problem here is that, for example, we can't modify cylinder since it's a grouping variable. Like we can't get, and here what we're trying to do is create a new column called mean, get the mean of cylinders. This case, I'd expect it to be something like 6 or something for all of them, right? Because that would be like the mean of the cylinders. Obviously, it depends on how many rows have 4 cylinders, how many rows have 6, and how many rows have 8. But I would expect it to be somewhere around 6, maybe, because it's in the middle. But here, what we're getting is we're just getting a repeat in this column of what we had in this first column. So here we can't modify cylinders. We can't get the mean of cylinders because we're using cylinders as a grouping variable inside the group by column. So before we can actually get the mean, we have to run this ungroup function. So here we just group by, we summarize to get these variables that are, yeah, if you want them, you can have them. And then we ungroup. And after we ungroup, we mutate to maintain all the previous columns and create a new column called cylinder, which we are reordering based on the mean miles per gallon, for example. So we're manipulating cylinder basically here. So we're reordering all of these based on mean miles per gallon from highest mean miles per gallon to lowest mean miles per gallon. In this case, again, instead of seeing the groups of cylinder displacement, you're seeing all of these different combinations with this extra mean miles per gallon variable. Actually, it's displacement variable. Sorry, well, it's extra displacement variable because you just put it in here. And you're also reordering by mean miles per gallon, so that is not going to help you very much. Any questions about this?
Yeah, I have a quick question about mean miles per gallon being reordered. It doesn't look like mean miles per gallon is in any particular order because it's it's not from highest to lowest, unless I'm missing something.
Yeah, you're right here. What I'm guessing is happening is that, okay, so it's what this reorder function does. If you look into that's a very valid question. If you look into the reorder function, it reorders whatever vector x, in this case, the vector is cylinder because it's just like a list of like 4, 6, 8, and it's reordering it based on the second argument, which is mean miles per gallon. What I'm guessing here is that it's putting 4 first because 4 has the highest mean miles per gallon, and then it is putting 6, and then it's putting 8. So like if you see 6 has like 19, 20, whatever miles per gallon, 8 has like 15, which is lower, and 4 at the start has like 30. So it's reordering the cylinder column based on that.
Okay, thank you.
Yeah, no problem. Any other questions? Great. So yeah, as Nico says, in here, ungroup can be a tricky error, or like it can be easy to miss in your code because it doesn't like change anything inside like the table. What it will do is allow you to keep changing variables in the future if you want to. So like if you did, for example, this chunk and then wrote or typed pipe and then ungroup, it would like make no difference on whatever you're doing. Just use ungroup if you're actually manipulating any of the variables that you group with the cylinder and gear later on. Okay, and final lesson, it is better to group by discrete variables such as cylinder. Cylinder is discrete because although it's numeric, there is a very limited amount of cylinders, 4, 6, and 8. Whereas displacement is kind of like a continuous variable here because it's numeric, and then it also has a ton of different values that it can take. So if you group by continuous variables such as displacement, keep in mind that if you have a very big range of that variable, your data set is going to have a big variety of groups, such as this case where we have like 27 rows for just like 3 different types of cylinders. So in some cases, this might be useful, but make sure that if you group by a continuous variable, you're making a conscious decision. Cool, that's the end. Any questions before we move on to the breakout rooms?
Phil?
Yep.
Could you just review about the discrete and continuous variables, especially if we have to make histograms? I remember we had a lesson where there was a discrete variable
Uh-huh.
and the histogram wasn't coming, and then you taught us how to change that. Did we do that? I'm kind of
Yeah,
missing.
sure.
We did it, I think third week or something.
Yeah, let me just download this super quick and we can go through that in a couple of minutes before we move on to BeginnR. Give me like 1 second. Okay, so basically, oops. The difference between discrete and continuous variables is that, for example, discrete variables can be like characters instead of like actual numbers. In this case, if we're graphing manufacturer on the x-axis, the different types of manufacturers are words. And there's like no like overlap between them. There's a limited set of words that we use, like Audi's different from Chevrolet, etc. So we can just like use a bar graph to display that, which we do through GMBar. However, for example, if we use a different sort of variable such as caret, caret is actually continuous. It's numeric, and there's like a very big range of values that caret can take, right? And since it's continuous, it's better to use a histogram. Basically, what the histogram does is it splits the data in your x-axis, so the caret, it splits into like different bins of the same size. In this case, the size of each bin is 0.01 carats. So for like, it starts counting from like 0 up to 1 like per 0.01 carat. And then in the y-axis, it displays how many rows have that range of carat, for example. So the histogram like groups them into different bins, and then just graphs how many occurrences happen there, because it is a continuous variable, so that is useful. And yeah, since it has a ton of different possible values, we call it continuous. In this case, for example, we have steady miles per gallon in the x and cylinder in the y. You would expect cylinder to be continuous because it is numeric, but as we see here, cylinder is actually discrete because there's only 4 different values. Like you have 4 cylinders, 5 cylinders, 6, 8. So even though it's numeric, that would be discrete. And that is why when you're doing a scatter plot, you're getting all your points in the same horizontal line. So that is a telltale sign of it being discrete. For this, for example, for price, again, there's a huge variety of X variables. So we're bidding them together every $50 and counting how many rows appear within each bin. So summary, geohistogram, you use them for one-dimensional plots. In this case, one-dimensional means that you only specify a variable for the x-axis. In this ggplot, when we did the aesthetic thing, the aesthetic function, we only specified price, which was the value for the x-axis. We never specified the value for the y. So that would be a one-dimensional plot. And since it's continuous, since price is continuous, we'd use a GM histogram. So like put them into bins and count. If we have a one-dimensional plot, for example, like this one where we only specified in the aesthetic function the manufacturer, that would be one-dimensional because we only specified the x variable, and we're just counting the number of occurrences in the y variable. That would be one-dimensional and discrete, so we use GMBar for that. However, when you have 2 variables, for example, an x and a y, and one is discrete, the other is continuous, you would use GMCall. It's the same thing as GMBar, only that you specify 2 variables instead of 1. So let me just move down to where we use GMCall. So here, for example, we're specifying destination for the x-axis and airtime for the y-axis. So those are 2 different ones. The destination is discrete, airtime is continuous. So it's the same. It does the same thing as GMBar, only that it works when we're specifying 2 different columns. However, if we have 2 variables x and y that are continuous, then it's better to do a scatter plot just with the points like this, because the bars are not going to be very useful in that case. If you want to add a trend line, GM smooth. And if you want to see where the bigger concentration of points is, it would go for GM hex.
So quick question, if we try a histogram and the bars are too far apart, then we need to adjust the bin width, is that correct?
Yeah, totally. So for example, what this example does is here it's getting caret, and as you say, the bars are slightly far apart. If you use a smaller bin width, so like here we didn't even set a bin width, so it's going to the default. The default here is that it's going to split the data into 30 different bins. So it's going to like see from 0 to like 3, split it up into 30, and each bin is going to be the same width. Whereas here we're setting a much smaller bin width of 0.01.
Okay.
And that shows you like a much more accurate picture.
Thank you so much.
Yeah, no problem. Great. We'll leave it at that and stop the recording.